Hello all. In today's session, we will study working of single phase voltage source inverter using transistor. What is a inverter? The inverter is an electrical device that converts DC input supply to a symmetric AC voltage of standard magnitude and frequency at the output side. It is also called as DC to AC converter. If the input source to the inverter is a voltage source, then the inverter is called as voltage source inverter. A full bridge single phase inverter generates a square wave AC output voltage on the application of DC input voltage. This is done by adjusting the switching on and off of the devices used in the inverter with the appropriate switching sequence. The output voltage generated is in the form of plus VDC minus VDC. Let us study working of single phase voltage source inverter. The circuit diagram is shown here. The single phase voltage source inverter, it consists of a bridge circuit which consists of four transistors T1, T2, T3 and T4. A freewheeling diode is connected across each of these transistors and the load is connected across the bridge circuit. The input given is a DC voltage or a DC source. Now let us study how this circuit works. So here I have shown the triggering pulses applied to the switches and the output voltage waveform. So initially a simultaneous triggering is applied to switch T1 and T2. So with this, switch T1 and T2 starts conducting and a current starts flowing from a DC source through T1, through load, through T2, back towards the DC source. So this direction of a current, it is considered to be the positive direction of current, and this voltage which is applied across the load is considered to be the positive voltage. So during this time period, the voltage appearing across the load is equal to plus Vs. Now at instant t by 2, switch T1 and T2 is commutated, and at the same time a triggering pulse is applied to switch T3 and T4. So with this, T3 and T4 will get turned on and the load will get connected to the source through T3 and T4. So now current starts flowing from source through T3, load T4 back towards source. So with this, the direction of current flowing through load will get reversed and the voltage which get applied across the load will also get reversed. So during this operating mode, the voltage appearing across the load becomes equal to minus Vs. At instant t, T3 and T4 is commutated and a simultaneous triggering pulse is applied to T1 and T2. So with this, T1 and T2 will get turned on and the same operation will be repeated. So what we are observing here that the nature of the output voltage waveform is a square wave. Now, as we have considered here the resistive type of load, and hence we are getting the output voltage waveform in a square form. Now, as this is the resistive load, so the output current and output voltage, these are in phase parameters. But if we connect here RL type of load, then in case of RL type of load, the current and voltage, output current and output voltage, these are not the in-phase quantities, but some phasor difference occurs between current and voltage. Now these freewheeling diodes, these will operate for this operation where RL type of load is connected at the output terminals of inductor. So during this phasor difference, diode D2 and D1 will get forward bias when switch T1 and T2 will get turned off, and whatever energy stored in this load due to the presence of inductance that freewheels through diode D2 source D1 back towards the load. So as the energy is getting freewheeled during this particular period, that's why these diodes are also called as freewheeling diode. Now frequency of the output voltage will depend upon this total time period T of one cycle of the output voltage. So if we vary this time period, then with the variation in the time period, the frequency of the output voltage and hence output current will be changed. Now here I have shown the equation for RMS value of the load voltage, then load voltage equation, then equation for peak value of fundamental component of load voltage, and equation for RMS value of fundamental component. Also, I have indicated here the equation of RMS value of a load current. Now, in case of inverter, we know that the output voltage, nature of the output voltage and output current is not purely sinusoidal, but we are getting the output voltage in the form of square wave. So it indicates that lot of harmonics are present in the output voltage and output current. So we can find the total harmonic distortion factor by using this equation. Now, what are the various applications of voltage source inverter? So a square wave voltage source inverter, it is used in the applications such as AC motor drives, uninterruptible power supply units, induction heating units, electronic ballast for fluorescent lamps, in HVDC transmission. It is also used as a solar PV inverters. So this is all about the working of single phase voltage source inverter connected to our load. Thank you.